welcome back to my YouTube channel. So today we are going to solve day 22 problem of this month on Leetcode. Before starting, if you guys haven't subscribed my YouTube channel yet, then please go ahead and subscribe it. Now without any delay, let's get started with today's problem. So today we are going to solve problem number 2583, kth largest sum in a binary tree. So in this problem you are given the root of a binary tree and a positive integer k. The level sum in the tree is the sum of all the values of the nodes that are on the same level. We have to turn the kth largest level sum in the tree, not necessarily distinct. Okay, and if there are fewer than k levels in the tree, then we have to return -1. Okay, note that the two nodes are on the same level if they have the same distance from the root. Okay, so let's understand this with an example here. So this is level 1. Okay, so in level 1 total sum is 5. Okay, and this is level 2, total sum here is 17. This is level 3 and total sum here is 13, right? And this is level 4 and at this level total sum is 10. Okay, so k is equal to 2. Okay, so here this is largest and this is second largest, right? So that is why output is 13 here. Okay, the level sums are the following: level 1 5, level 2 17, level 3 13, level 4 10, and the second largest level sum is 13. Okay, so now how we are going to solve this problem? Okay, we are dealing with a level wise sum, so let's use BFS here. Okay, so this is a simple application of BFS. So here how I'm going to do this. So BFS simply means that we have to use queue. Okay, so here let's create a queue. Okay, so let's say this is my queue. Okay, so here what I'm going to do at level 1. Okay, this is my root, right? 5. So I'm going to insert this 5 in my queue. Okay, I have inserted this 5 in my queue. Right now, after that, what is the current size of my queue? Right now it is 1. Okay, so let's just add all the elements in my queue. Okay, at this particular level. Okay, because only 5 is there, right? So in the starting total sum is going to be 5 only, right? Total sum at level 1 is going to be 5 only. And what are the children of 5? I'm also going to add side by side the children of 5. So children of 5 are 8 and 9. So I'm going to write 8 here and 9 here. Okay, and I have already calculated level 1, so I'm just going to pop this. Okay, remove this from the queue. Okay, so now current size of queue is 2. Okay, so this is nothing but my level 2. Okay, current size is 2 here. Okay, so now I have to do the summation of all the elements right now which are in my queue. Okay, I have to run one loop. Okay, for 2 times for 2 elements. Okay, so 8 plus 9 is going to give me 17, and for both 8 and 9 I have to add the children's. Okay, so here 8 children is 2 and 1, and the children of 9 are 3 and 7. Okay, 3 and 7, and I have already calculated the level 2, so I'm just going to remove this. Okay, so now what is the current size of my queue? Current size is equal to 4. Okay, so now after inside this I have to run one for loop. Okay, to calculate all these values. Okay, to calculate the sum of all these values. So total sum is going, I'm going to get is 2 plus 1 plus 3 plus 7 is equal to 13, right? This is what I'm going to get. Okay, so this is done, and side by side I'm also going to add the childrens of all this. So children of 2 is 4 and 6, so I'm going to add 4 here and 6 here. Okay, and then children of 1, no children, 3 no children, 7 no children. Okay, so I have got all the children of this level 3, right? So now current size of my queue is 2. Okay, so here for this I am going to do the summation. So total sum I'm going to get is 10, and after that there are no children, I'm going to remove it. Okay, my queue becomes empty, I have to stop this. Okay, and side by side I'm also going to maintain my MinHeap. Okay, let's use MinHeap. Okay, MinHeap. And in MinHeap what I have to do? Okay, so initially at level 1 I got this sum, at level 2 I got this sum, at level 3 I got this sum, and at level 4 I got this sum. Okay, so first I got this sum, min heap is empty, I am going to add this 5. Okay, my k is 2, k is equal to 2 here. Okay, my min size is right now is 1. Okay, all right, then after that 5 I got this 17. Okay, now I have to insert this 17, right, since this is min heap. Okay, so 5 is going to be go to the top. Okay, and then 17 is going to come at this place. Okay, right, this is done. Okay, so here size becomes 2. Okay, my min heap size becomes 2. All right, now after that 13 wants to come, right, 13 wants to come. Okay, so 13 where this 13 will come, so this 13 will come here, right, this is min heap, so 13 will come here and 5 will go here, right, this is how. But here I'm saying that my k is 2, so I just need two elements, right, only two elements in my min heap. Okay, so bottom one always going to be largest, and after above this is going to be my second largest. Okay, so we don't need to use this 5. Okay, so whenever my min heap size becomes greater than k value, I'm going to remove topmost element. Okay, this is done. And then after that I want to insert this 10. Okay, so 10 will come to the top. Again my min heap size become 3. Okay, greater than k, so I'm going to remove this. And in the end what I have to do, I have to just return the topmost element from my min heap, which is nothing but 13. That's it. Okay, easy. So that's what we need to do. Okay, now let's write the code. So code is also going to be very simple for this one. Okay, let me just remove this, this is not required. Okay, so this is a structure for this tree node. Okay, so we have value, we have left and right of for a tree node. Okay, and this is my tree node, I'm calling this. In this, if I'm passing this value, I'm returning that value. And in tree node, what are the three different things? One is value, one is left node, and one is right node. Okay, so this is what I have. Okay, this is the information that I am going to use in my code. Okay, so now what we need to do here, so first thing, just check one base condition. If root is equal to null, then in that case simply return -1. Okay, done. Then after that we have to create min heap to store the k largest level sums. Okay, so use priority queue, and in this priority queue what we are going to pass, we are going to pass the long type. Okay, and here let's name it as min heap new, and here inside this I am going to maintain size as k only always. Okay, so that's it. Then we have to use queue for the level order traversal. Okay, so queue, and in this queue what I'm going to pass, I'm going to pass three nodes, right, and three nodes will have the information like the particular node value, the left children and right children. Okay, so here let's name it as queue new linked list. Okay, and initially just pass the root value. Okay, q dot offer root. Okay, I have passed this node, root node. Okay, then we have to perform bfs, which is nothing but level order traversal. Okay, perform bfs, that is nothing but my level order traversal. Okay, so here I'm just going to write while my queue is not empty. Okay, now inside this, first let's calculate the size of my queue. Int size is equal to queue dot size. I've got the size. Now level sum, level by level we have to calculate the sums. Okay, so here I'm just creating one variable level sum and set it to 0. And now I'm just going to sum up all the nodes values at the current level. So here run one loop for int I is equal to 0, I is less than size, and I plus plus. Okay, and here inside this take first current node. Okay, current current node is equal to q dot poll. Okay, remove that. So q dot poll, side by side I'm going to add everything. Okay, do everything. everything here. I'm polling this current element, current node, and this current node I have to add this into my level sum. Okay, here write current node, add this. Okay, now side by side let's add the left and right children of this one as well. Okay, so add children to the queue for the next level. So for that purpose, if my current node dot, okay, here left is not equal to null, okay, then we have to add this. So queue dot offer, and here I have to just pass current node dot left. Okay, so can I copy this? Yes, copy this and paste it here. Okay, this is done. Now same way we have to do this for the right as well. So copy this, paste it here, and instead of this left, just write right. Okay, and here q dot offer current node dot right. Spelling mistake. Okay, so this is done. Okay, so here we are doing all this stuff. So here my this for loop ends. Okay, so once I calculate the sum, okay, for that particular level and added all the childrens in that, then after that what we need to do here, we have to maintain the k largest sums using a min heap. Okay, min heap dot offer, and here we have to just add level sum. Okay, now once this is done, then after that, if my min heap, okay, I have told you, if my min heap dot size becomes greater than k, then in that case just remove the topmost element. Okay, so here min heap dot poll. Okay, so we are going to remove the smallest sum if heap size exceeds k. Okay, so this is done. Okay, and here if you see here my while loop ends. Okay, completely processed all the level order by sums right in the while loop. Okay, so I have calculated all the level sums and added them to the min heap. Okay, so once this is done, then what we need to do, so if my min heap dot size, okay, if size is less than k, then we have to return -1, that's given in the question, right? Return -1. Okay, if there are fewer than k levels in the tree, return -1. Okay, and here otherwise we have to just return the root of the min heap contains the kth largest level sum, which is nothing but min heap dot peak dot peak. Okay, so now let's run our code and see if there are any code issues. So yes, here level sum is equal to level sum plus current node. So here I think this is the level sum that I'm using here. Okay, level sum is equal to current node dot value. Okay, so current node dot val. Okay, we have to add value now, that is missing. Okay, so here current node dot value. Okay, let's run it. We can add value only now. Here current node dot left is not equal. Okay, this dot just now I have added, I think. Yeah, so see, all the test cases has been accepted, right? So now here uh, we are getting like this. Okay, so 2137. Okay, so here one more thing, so we are getting 13 here, right? 17, 13 is the second largest, right? So now in case, let's say, I just want to show you one more thing here. 2137. Okay, so here if I write 7 here in place of 3, then what will happen? Let's run it. Then what we are getting? We are getting 17 only. Okay, 17, 72 times. So that's the meaning of this line. uh, 1 second, somewhere that line was written. The level node is the sum of the nodes that are on the same level. Return the care. No, oh yeah, not necessarily distinct. Okay, so we don't care about the distinct. Okay, so if two are same, then just consider this as second largest. Okay, it's not like 17, 17, 13, then consider this as second largest. Okay, so not necessarily distinct. This is the meaning of the sign. Okay, So yeah, and one good thing, right, we can diagram is also getting changed, right? Here if I'm writing 5, here 5 is displayed. Here if I'm writing 50, so 50 is there, right? Good feature of Leetcode, right? So now let's submit it. So see, our solution is accepted, right? And let's check the time complexity from here. Let's see if it is accurate or not. So yeah, it is accurate, of n into log k. So why? Since we are traversing over all the elements in my queue one by one. Okay, so here for the complete traversal it is going to take of n, okay, for all the elements. But here min heap, okay, so in min heap priority queue we are using, okay, so in this we are adding the elements, removing that elements, so that always take total log k, okay, log k time complexity, okay. And to overall I can say of k log k, where k you can say is the number of levels that we have, okay. So if k is very large, so in that case you can say of n log n, okay, for this. So overall time complexity is going to be dominated by priority queue step that we are using, okay, the min heap step. So I will say that time complexity is going to be of n log n, okay. So I hope that you guys are able to understand today's problem. If you guys still have any doubts, then please feel free to ask in comment section. Till then, keep coding and keep practicing. Meet you guys in the next video. Thank you. Bye bye.